Hi, Dr. Scott Viers. I'm with Beam Reach, and I'm excited to talk to you today about Orcasound. It's a story of hydrophones and hackers, and I'm going to try to summarize some open source solutions for acoustic detection and tracking of Salish Sea marine mammals that I've helped develop along with a wide range of collaborators over the last 20 years, and especially the last 5 years. I'm excited to share how acoustic and visual data may inform the oil spill responses in the Salish Sea. Orcasound is a hydrophone network, and that's how we started in the early 2000s, expanding from previous efforts at Lime Kiln State Park over decades. And in the last few years, Orcasound has also become an open source software community, as I'll try to explain today. Currently, we have 3 cabled nearshore sites in the critical habitat of southern resident killer whales. All 3 sites have been streaming live 24/7 since throughout 2020 and 2021 in the modes that I'll describe to you today. Fundamentally, we are a citizen science or community science project with the goal of detecting killer whales in real time. And you're welcome to join us at live.orcasound.net, where we continue to evolve our web app, our browser-based tool for community scientists. Since September 2020, we've also been using a real-time inference system developed by Microsoft Hackathon volunteers over the last couple of years in collaboration with Dave Bain and again, a wide variety of data scientists around the world. And all of our software is summarized in what are called repositories. So if any of you are interested in contributing to our efforts or examining under the hood how all of this works, it's all documented at our GitHub repositories, github.com/Orcasound. But the fundamental thing that our crown jewel is this web app that allows you to listen live to the hydrophones and then indicate when you hear something interesting. So a bit more about the network, just for context. We have had up to 5 locations, including as far south as Seattle, and Vashon Island most recently is coming online through a partnership with Sound Action, one of the latest NGOs of 15 who have joined this cooperative effort. We've also been as far west as Nia Bay in collaboration with the Makah tribe historically. But at the moment, the 3 locations are Orcasound Lab on the west side of San Juan Island, Port Townsend Marine Science Center hosting a Port Townsend node, and Bush Point, hosted by Orca Network on Whidbey Island. So I've mentioned this evolution of NOAA funding in the early years that allowed expansion to 5 locations. And then more recently, in the last 5 years, what I'll talk about a bit more today is how we've continued to evolve and persist through crowdfunding and increasingly volunteerism through open source code development and also crowdsourcing of data problems like labeling and annotating data to train machines. We really have grown from a couple of individual scientists trying to develop these tools to a really wide community, in part through things called hackathons, group efforts that leverage all of the tech talent we have here in Seattle. So whereas we began with MP3 streams and custom software on Windows boxes, now we're using Raspberry Pis to stream the audio data and web applications to listen to the live data, cloud-based storage to store the audio data and to analyze it. And all of this has, this openness of open data and open licensing has manifested in a proliferation of different projects that leverage the hard work of all of our community members in building hydrophones and deploying them and maintaining them at each of these locations, but also working on sharing data and analytic techniques and deriving new ones. So I'll just emphasize that hydrophones are still the majority of our costs. We've got most of our hardware costs down to just a few $100s, but the hydrophones are still what cost the most and break the most often. And I'll just highlight that we have a lot of different software products, but the main one is this live listening app and the AI assisted sort of machine learning pipeline that's become part of it. So let me just go over the data flow quickly. Basically, we have built this data flow from hydrophone to headphone, the citizen scientists creating events or detections, but also machines using the same archived cloud-based data to generate detections. There's also been, over the past year or so, clearly a need to moderate all of the detections, not all of them, but some of them. So we're developing interfaces for moderating or validating human and machine detections. You can learn more about our AI projects, both Google Summer of Code projects and more recent collaborations with Canadians in the Allo project. But I'd like to just highlight that in addition to tools that we've built for annotating data, the real-time inference system has been operational for the last year or so and is proving to be a great complement to the human listening effort. That said, I believe that for the foreseeable future, a combination of AI and humans is really the optimum. If your goal is to know in real time with great reliability where southern resident killer whales have been heard, it's still important to have humans in the loop. But the machines are absolutely helping us, particularly when the human listening effort is minimal, like in when most of us are sleeping here in Western Washington. I wanted to emphasize that a lot of the work we've done in the last few years has been in collaboration with many of the NGO partners that I've mentioned, including Orca Network. And so Susan, I'm sure will have spoken or has spoken about the amazing sighting network that we have here in Puget Sound proper, south of Admiralty Inlet and around Whidbey Island. Similar community science projects exist on Vancouver Island in Canada, the Gulf Islands, and the San Juan Islands. All of these are poised to be combined with a growing number of acoustic assets, including R3 locations, with more planned. So I'm most excited about the possibility that oil spill response in the Pacific Northwest across the Salish Sea can really leverage all of this new technology and the increasingly well-developed and organized networks, human networks that underlie both the sighting and the listening efforts here, at least here in Washington State. So as an example, this is the last 90 days of acoustic and visual detections of southern residents and Biggs killer whales. And you can see that the data density is quite high, and when Orca Network and the other sighting networks in South Puget Sound are activated, that every few kilometers, every half hour, you get a new location. These certainly contextualize and help us understand when to listen. But there are also cases where sometimes on a foggy day or in the middle of the night, the sighting networks aren't very active or effective. And the first detections are acoustic detections. So the efforts have grown together, and I see them poised to grow closer together. And to georeference the sighting data and associate it with the time-stamped acoustic data is already happening, but it could be, with some small investments, I think it could be improved greatly. I also wanted to mention that what I'm talking about today is Orcasound, but there are many other assets, particularly in Canada, that should be thought of and kept in mind when developing acoustic complements to an oil spill response system in Washington State. So there are Ocean Networks Canada. There's infrastructure funded by ECHO and DFO. and nonprofits like Simres. All of these should be kept in mind. And there are parallel efforts in Canada to integrate acoustic and visual data that I hope we can build upon and complement with our efforts. Ultimately, I think they should all be coordinated in case we get a transboundary spill. So I'm looking forward to increased data sharing across the border and deployment of all that we've built on any Canadian assets that might benefit from it. Finally, I wanted to know, to just mention in passing that one of the experiments Beam Reach has been doing in collaboration with Protected Seas, NGO based in California, is testing a marine monitor, so-called M2 system, at the Orcasound lab location on the west side of San Juan Island. And I just raised this as, in the event of an oil spill, it may be important to know the location of not just AIS-equipped vessels, but vessels that don't currently carry AIS. And this system has proven to be remarkably helpful in understanding and contextualizing what we hear through the Orcasound Lab hydrophone. And I think that either as a tool for helping us understand what vessels are in the vicinity before an oil spill or were involved in an oil spill, or even are involved in the response itself, this is a pretty amazing tool. I also flagged this because an opportunity I see that's a little off topic for my talk today, but I think is interesting, is that the same infrastructure that we use to listen for killer whales and other species of concern that are soniferous could be used to listen to ships more carefully than we do currently. At the moment, ships and boats typically are just noise sources that interfere with our ability to listen to the beautiful sounds of killer whales. But all this AI infrastructure and the ability for humans, some of whom might be trained as sonar techs, to listen carefully and more carefully to ships is something that I think could be valuable in terms of even preventing oil spills. So imagine a database of ship noise signatures, and every time a vessel that could cause an oil spill goes past our hydrophones, we could be comparing how it sounds today in real time with how it sounded in previous passages. So that may be a way to flag when a ship is having an issue, like a bearing issue, or you're hearing shaft rub, or maybe propeller damage, something that might lead a pilot or a captain to a situation in which an oil spill might happen. So I'll just flag that as an interesting place where we may be able to leverage the hydrophones we already have in the water for other purposes within the oil spill response system. Well, thank you. I just want to acknowledge that this really has been a community effort. It's definitely taking a village, and I don't understand everything that's getting built at this point. So I invite you to join us at orcasound.net to collaborate more closely and openly. I want to thank specifically the Microsoft Hackathon volunteers who, along with Dave Bain and Orca Conservancy, helped build the real-time inference system we've been benefiting from. Also, AI for Earth gave us some credits, along with Amazon, that's made all of this financially possible. And I'm very excited to keep collaborating with both the Canadians in the next couple of years and Protected Seas on the ship tracking systems, vessel tracking systems. Thanks very much.